Okay, welcome back. Now, today's our topic is vector analysis part 2. Here A is a vector which is a function of time t, and we are going to find derivative of a vector. How to find a derivative of a vector? Let's find normal derivative. So vector A, which is a function of t, can be written in rectangular coordinates like axt, I, ayj, azk, and all are function of t. That is, all components are function of t. So if we take derivative of a, that is derivative, which is I dax dt plus j day dt plus k daz dt, that is derivative of all the components. And next, find gradient. Gradient is an operator. It's a kind of derivative. Gradient means it's a derivative with respect to space. So let's find gradient of some scalar phi. Grad phi equals to I del phi del x plus j del phi del y plus k del phi del z. Gradient is a vector operator, so we can apply it only a scalar. So the upside down triangle is a gradient operator, which is also called del or nabla. Here we can write this information: d phi equals to grad phi is a vector normal to the surface of phi xyz at every point. After derivative, we can start divergence. It is also a special type of derivative. So divergence of a vector A. Here del operator is a vector operator. So we take dot product of del and another vector A, which is I del del x plus j del del y plus k del del z dot ix plus jiy plus kaz, and simply the dot product result is del ax del x del ay del y del az by del z. So this gives a scalar result. If divergent A, that is del dot A equals to 0, then the A vector is said to be solenoidal vector or incompressible vector. The incompressible word is used in case of liquid, that is fluid flow. Curl of a vector. The vector product del cross A defines the curl of a vector A and written as in a matrix form like ijk del del x del del y del del z and ax ay az. It is obvious that curl A is a vector function, unlike divergence A. If curl A equals to 0, then the vector A is classified as irrotational and conservative vector, and in that case the vector can be written as gradient of some scalar function phi. The physical interpretation of the curl of a vector is related to the rotation or circulation of a vector field. Laplacian. Del square is a scalar operator and is known as Laplacian operator. The Laplacian phi equals to divergence of grad phi, and it is written like del 2 by del x2 plus del 2 by del y2 plus del 2 by del z2. that is Laplacian phi equals to del 2 phi del x2 plus del 2 phi del y2 plus del 2 phi del z2. Vector integration. In general, ordinary vector integration is like the integration of scalar. Let's suppose vector A equals to a function of u, where u is a scalar quantity. Then integration of vector A du. This can be written as I ax du plus j integration ay du plus k integration az du. That is, all components are function of u, and this is called indefinite integral of a vector function a. Integration constant must be of same nature of the integral. Now this vector integration that we are going to talk are in three forms, like line integral, surface integral, and volume integral. Line integral, it is also called tangential integral, which indicates integration of a vector along a curve between 2 points, that is p1 to p2, and it is defined as integration p1 to p2 vector a dot dl vector equals to integration p1 to p2 a dot dl cos theta, that is in form of dot product. And in Cartesian coordinate, integration p1 to p2 ax dx plus ay dy plus az dz. It is the most common form of the line integral, and you see this result gives us a scalar quantity. The work done W by a variable force F in moving a object from P1 to P2 is defined as W equals to integration P1 to P2 F dot dl. It's an example of line integral. So let's derive it from Newton's second law of motion. F equals to m dvdt, and we put it in this equation, and it becomes m integration 1 to 2 dv dot dr dt. So doing some calculation, you see in the screen, we finally get work done W equals to half m v2 square minus v1 square, and it is the change in kinetic energy. So work done is change in kinetic energy. This proves the work energy theorem. So for conservative force, curl of F equals to 0, and then we can write the force F equals to gradient of some scalar function, say phi. If we put in this equation, W equals to F dot dr, that is integration grad phi dot dr, that is integration d phi. If we take this closed path, then for closed path integration d phi equals to 0, which means the total work done in a closed path is 0. That indicates conservation of energy. corresponding f is called conservative force. Surface integral. Here consider a surface in the field of a vector A of any type or any shape. First we have to divide this surface into a very small elemental area ds. We see in the black rectangular box, that is ds. So for this area ds, a dot ds equals to a ds cos theta, and it is called the flux of a through that area ds, where theta is the angle between a and ds vector, or it is the angle between a and unit vector n, where n is a positive unit normal to the area ds. So now the flux of vector A through the whole surface is double integral, that is surface integral A vector dot ds vector, which is equals to A ds cos theta under this double integration. So you see this A cos theta represent the projection of vector A on this unit vector n. So in Cartesian form, a dot ds equals to, we write in this form, as dsx plus ay dsy plus az dsz dsz within this double integral. The volume integral of a vector, it can be written like triple integral, that is volume integral vector A dv, where V is the volume enclosed by a closed surface S, and dv is infinitesimal volume in that field, which is dx, dy, dz. Now discuss about integral theorem. There are three integral theorems. One, Gauss divergence theorem. 2, Stokes' theorem. 3, Green's theorem for plane. So Gauss divergence theorem, this is an integral theorem about the transformation between surface integral and volume integral. So double integral a dot ds equals to triple integral, that is volume integral divergence dot a dv. So for Cartesian coordinate, we can write this formula like this. You can see in the screen. Now Stokes' theorem. It is an integral theorem about the transformation between line integral and surface integral. So here this surface is bounded by this closed curve L. Now integration A dot dl equals to surface integral curl of A dot ds. Next, Green's theorem for plane. So, close integral m dx plus n dy. It can be written in double integrand r, that is the projection, del n del x minus del m del y dx dy.